We also see another commonality that pops up when looking at the gravitational field equation from a source's perspective. We see that the gravitational field equation is gm source over r squared, which is the exact same equation we got for the acceleration due to gravity created by a planet. And that makes a lot of sense because if we go back to the definition of gravitational field acting on an object, it's the force divided by mass. Acceleration is the net force on an object divided by the object's mass. If gravity is the only force acting on an object, then that force of gravity on the object is in fact the net force. And so then that force divided by the object's mass must be acceleration. In fact, even if we take a look at the unit for gravitational field, which is a Newton per kilogram, we have to realize that a Newton is actually an abbreviation. A Newton is a kilogram meters per second squared. If I divide that by kilograms, the kilograms cancel out, and I'm left with simply meters per second squared, which is the unit for acceleration. So if I know the free fall acceleration for a planet, I automatically know its gravitational field strength because they're always going to be the same value. It is important to note that this is the only field that will have the same value as acceleration. None of the other fields have this relationship, and that's because none of the other fields are created because of mass. Only gravity is created because of mass, and so its field strength would be equal to the acceleration tangential that it would experience.